True that. Starting chapter 10. Rational expressions. Don't tell me it's dat. I learned how to say my TEH sounds. Well, of course, if it were my son saying it, he'd say, yeah, if you don't know the TH sounds correctly, you could be like my son and say it, who fat? That's going to be a whole other set of problems. All right, so a rational expression it's a quotient, which means it's a fraction, so you cannot escape it. It's going to be the quotient of two polynomials. It's the quotient of two polynomials, so P divided by Q, where Q does not equal the zero polynomial. We've been over this before. You do not want the denominator of your fraction to be zero. It's not going to go well. Now, examples of rational expressions. And just to remind you here, when you see rational, you see ratio. So that means we're talking about fractions. Because later on in the next chapter, we're going to talk about rational exponents. And those are exponents that are written as fractions. Oh yeah. So you could have examples like this. 3/5. You could have x plus 7 over x minus 9, making things a little bit more complicated. You could, yes, you could have things even super duper complicated. X to the 138th minus 7x plus 2. Oh yeah, he did. All over 2x squared minus 11x minus 6. See, they can be simple, they can be complicated, and what we're going to do is we're going to learn to work with these guys, and we're also going to talk about all the basic things we've ever done with fractions, but now with things that are a little bit more complicated. So when we talk about fractions, we talk about multiplying, dividing, adding, and subtracting. We're going to do that with these guys. That's what we're going to do today. And then later on this week, we're going to talk about complex fractions, basically fractions within fractions. We'll talk about solving equations that contain these guys, and word problems and applications. Can I get an all ye?
Oh, no.
Huh. Oh, snap. So when we talk about these guys, we also want to talk about restricted values. You guys remember when we talked about domain a long time ago? The domain was a set of x values that we used to make up a function or a relation or an expression. Okay. So when we talk about restricted values here, restricted values have a direct connection with domain. Okay, restricted values. Okay, this is going to be any replacement of the variable, that makes the denominator equal 0. Any replacement of the variable that makes the denominator equal 0. That's going to be a restricted value for us. Now if we look at the expressions that we have here at the top, if you look at 3 over 5, 3 over 5 has no restricted values. Okay? This denominator is 5. When does 5 equal 0?
When is negative?
My denominator is 5. When does that expression equal 0? Can 5 on its own ever equal 0? No. So there's no restricted values for this expression. Any value of x would be okay. I mean, there really isn't even an x here. So there's no value of x that causes us problems. If I look at the next guy, x plus 7 over x minus 9. The question here is, what will make the denominator equal 0? Because whatever makes the denominator equal 0 is a restricted value. That's the guy that we have to avoid, we have to watch out for. So here, your question really should be this. What value of x makes the denominator x minus 9 equal to 0? When does that denominator equal 0? When x is 9. So if this is the question, what value of x makes x minus 9 equal 0, then your answer is going to be the value x equals 9. So what I'm saying here is that in this expression, I could plug in any value of x that I want to, and I'm going to get some answer out once I plug in that value of x. Except if I were to plug in 9. If I plug in 9, I get 16 in the numerator. That's not a problem. The problem happens in the denominator. If you plug in 9, what's 9 minus 9? 0. What happens when you divide by 0?
You get 0.
You don't get 0, but your expression is undefined. When the 0 is under the line, the expression is undefined. Okay? Maybe you should put that as a tattoo so you can always remember that. I should have my own tattoo parlor. We'll call it, we'll call it like a math tube parlor. That'd be awesome.
You have a bag full of math problems.
Oh, you tell me, I bet there's somebody out there who's super cool and has his or her body completely tatted up in math formulas.
And that super broken book.
It's a very small intersection there.
Non-existent.
Don't judge me. I know that's what you're doing. All right, what if I take this guy right here? I want to find out what values of x are bad for this guy. Where do I need to look to find those restricted values?
The denominator.
The denominator. So what I need to do here is figure out what makes this denominator, 2x squared minus 11x minus 6, when does this guy equal 0? That's what I'm trying to find out, because when I know, if I know when this guy's equal to 0, then I know the values of x that I can't use, right? Just like if you know that somebody is coming over to your house to eat supper, it's usually a good idea to find out what they're allergic to so that you don't cook with that, right? Like, or
You ask me when I'm cooking.
for example, I am very allergic to onions. So when I go eat at my in-laws' house, and if they're making a dish that has onions, they make sure to set some stuff aside for me that doesn't have onions, because they know what will set me off, basically.
Right.
So that you avoid that, and that's what we're doing here. We're trying to find out what makes this denominator equal to 0, because when I know what makes it equal to 0, then I'm going to avoid using those values at all. Right? Unless you're an evil cook, like some people in here. Oh, you're allergic to peanuts.
No.
Yeah, there are no peanuts in these peanut butter cookies. That's completely
No,
nut-free.
That's not how it happens.
So let's go ahead and solve this guy. It equals 0, so that means I need to do what now?
Factor.
Factor. It's a nice trinomial that doesn't have a common factor other than 1. So I'm going to go straight to my 2 sets of parentheses. See how I'm always looking for that GCF? Because that's how I roll.
2x plus 1, x minus 6.
You sure about that? Because I'm using marker here, so if this is wrong, I'm going to be a little upset.
Plus 1, x minus 6.
2x plus 1, x minus 6, is that right? I get a minus 12 on the outside,
No.
plus 1. What's negative 12 plus 1?
11.
Negative 11.
Negative 11.
Boom.
Oh, yes, right. Because we're trying to, okay.
Now let's keep going here. What makes this guy equal to 0? X equals 6. What about this guy right here?
Negative 1.
Negative 1 half.
So these are my 2 restricted values. These are the guys that I can never use in this expression, right? Now here's something that we may say, because we're talking about how this connects with domain, right? Bless you. So my domain is going to be the set of all x values such that, so I draw a little vertical bar, such that, well, I can use all values of x as long as x does not equal negative 1/2 and x does not equal 6. So as long as I don't use those guys, then I'm okay for this expression. Are you with me on that? Just like in this last one right here. The domain for this guy would be the set of all x such that x does not equal 9. Do y'all agree? Now, another way of saying this, if you're using interval notation, is that the domain is from negative infinity to 9, not including 9, and it would pick back up on the other side of 9 and go on toward infinity. So two different ways of saying the exact same set of numbers. Here I'm saying the domain is all x as long as x doesn't equal 9. And here, if I look at it in terms of a number line, this is everything except for what? Except for 9.